Welcome back. This is part 7. It's on solving polynomial equations. We'll go through a couple of definitions first here. The preceding sections on factorization allow us to now solve any polynomial equation. A polynomial equation of the form px equals 0 may be solved by factorizing px first and then applying the null factor law. So for example, if we had px is x squared plus 5x plus 6, and we factorize that first, that would be x plus 2, x plus 3. So if you want to solve the equation px equals 0, that means we try to solve x plus 2 times x plus 3 equals 0. And the null factor law states that AB equals 0, then either A is 0 or B is 0. So this is equivalent to AB. So that's telling us that either A is 0 or B is 0. So to solve the equation, x plus 2 must equal 0 or x plus 3 equals 0. We can use brackets or not, doesn't matter. So in this case, x must equal minus 2 or x equals minus 3. This is your null factor law being applied here. So you could have questions with 3 factors, and these would be the solutions here. So we'll do a quick one. 3x plus 1, x minus 2, x plus 5. So if you want to solve this equation, either 3x plus 1 equals 0, or x minus 2 equals 0, or x plus 5 equals 0. So in the first case, x must be minus 1/3. To bring the 1 over and then divide by 3. In this case, x must be 2. In this case, x must be minus 5. And these would be your solutions to the equation here. That's for a cubic polynomial, but any polynomial works the same way. This section here is on Vieta's formulas. I won't discuss that now. You'll need this a little bit later when you see your workbook. It's not relevant to this section of work we're going to do today. So looking at some examples, we want to write down the roots of the polynomial equation. So roots are your solutions. Or another word is zeros, which we'll talk about later when we do graph. Okay, so in this case, we've got a cubic polynomial, and we want to solve this equation. In the first case, we see x written. That's really the same as saying x minus 0, okay, because x minus 0 is x. Then you've got x minus 2, 2x plus 3 equals 0. So in this case, x in the first case must be 0. Okay, so if this is 0, then it doesn't matter what these are, your answer will still be 0. In the second case, x minus 2 must be 0, so x there would be 2. In the third case, x must be minus 3 on 2. So just rearrange that equation. 2x plus 3 equals 0. So these would be your 3 solutions to the cubic polynomial. In example 12, our first one is x cubed minus 4x equals 0. So before you start any polynomial division, take a look at your question. This question we can immediately factorize without any division. So take out x as a common factor, you'll end up with x squared minus 4. equals 0. Now you should recognize this part here as a squared minus b squared, which is the difference of squares. A minus b, a plus b. Okay, so we'll apply that here. So you'll have x squared minus 2 squared. And then we use the difference of square rule here to factorize that. So x minus 2, x plus 2 equals 0. Okay, so in this case, again, x here would be equal to 0, and then you'll get a 0 answer. In this case, to make this 0, x must be 2. For that one there. And in this case, x must be minus 2. Those are your 3 solutions for that question. In question B, we've got x cubed minus 8x squared plus 16x equals 0. Notice there's no constant term, and if you look at this question, you can see that x would be a common factor. So you factorize out x first. So x times x squared minus 8x, because minus 8x times x is minus 8x squared, and that would be 16 equals 0. So can we factorize this quadratic? That would be x minus 4, x minus 4 equals 0. So in this case, x would be, let's write it here, x would be 0 from the first factor. X in this case is 4, and in this case is also 4. So this is actually called a repeated root. Because we have, in this case, we have 2 of them, but we don't need to write it again. So you don't need to write 4, 4. You just write it once. This will become important when we start doing graphs, when we have repeated roots like this. Okay, in part C, we need to first look at the question for any common factors. We've got x cubed, x squared, x, and a constant, and there's no number which is a common factor. So we're going to have to guess a factor first. We guess a factor, and we use the factor theorem to do that. So look at the last term, minus 9. So what are the factors of minus 9? Minus 1 times 9, 1 times minus 9, 3 times minus 3, and minus 3 times 3. So we've got plus or minus 1, plus or minus 3, plus or minus 9. We only need one that works. So these are your A values, what we were calling in the last couple of videos. So if we let P1, so we want to see, does this equal 0 or not? If it does, then we know that x minus 1 is a factor. So let's try 1. We'll get 2 times 1 cubed minus 11 times 1 squared plus 18 times 1 minus 9. Now does this equal 0? 1 cubed is 1 times 2. 1 squared is 1 times 11, okay, minus 11, plus 18 minus 9. So this is minus 9 plus 18 minus 9. So we can see we're going to get minus 18 plus 18, which is 0. Good. Which means that x minus this number is a factor. So that means now we can divide x minus 1 into our polynomial to find a quadratic polynomial. So 2x cubed minus 11x squared plus 18x minus 9. So we'll end up with 2x squared times x, which is 2x cubed, 2x times minus 1 minus 2x squared. Then we subtract minus 11x squared plus 2x squared. That would be minus 9x squared. Bring down your 18x. This will be minus 9 minus 9x times x minus 9x squared. Minus 9x times minus 1 would be plus 9x. Then we subtract that. 18 minus 9 would be 9x minus 9. So the last term must be 9. 9 times x, 9x. 9 times minus 1, minus 9. And when you subtract, you get 0. So that means our x minus 1 is the correct factor. So what we ended up with, x minus 1 times 2x squared minus 9x plus 9 equals 0. So this is our first factor. This is a quadratic factor. Can we factorize this? What do we get as our factors? 2x minus 3 and x minus 3 as the other two factors. You can expand that and check. Okay, equals 0. So what are our roots? What are our solutions? In this case, x would be 1. In this case, x would be 3 on 2. In this case, x would be 3. So those are your three solutions. That's all you need to do. So in exercise 7, these are your questions. So look first if you can actually factorize anything first. Okay, so in the first question, you can. You'll have 2x as a common factor, then you'll have x squared minus 25. And then it's easy to get your solution from these two here. And there will be two solutions for this one, for this difference of squares. So in these questions, you want to group together x cubed plus 20x minus 9x squared. You can probably put that next. So x cubed minus 9x squared plus 20x equals 0. And then you can see a common factor here. X is a common factor. Right, so do that for question 1 and write each value of x. Factorize first. So these ones you're going to need to follow the last example, example C. Okay, and then I want x to be possibly 3 numbers. And I want you to do that for each question there. There are 6 of those. Okay, so good luck with that, and I'll see you in the next lesson.